and a Master's of Computational Biology in 2004. He was funded by both the National Science and Engineering Research Council of Canada as well as the Alberta Ingenuity Fund. He completed his dental degree at the University of Alberta in 2007. His authored papers range from computer simulations to protein purification and structure, where his work appeared on the cover of Biochemica Acta and DDS letter. He currently operates a small clinic in the suburbs of Calgary. He's an accredited member of the IAOMT and currently sits as the chair of the Scientific Review and Clinical Practice Guidelines Committee. And I can only say, having taken a scientific review through Kindal, how he sharpened my review, and I'm very, very grateful for this man. And so I give you Kindal Robertson.
Thanks, Stuart. Stuart has done some incredible science actually with osteonecrosis of the jawbone, so I'm really glad that he's the one who introduced me. Okay, so the title of the topic today is Show Me the Science, which is actually the motto of the International Academy of Oral Medicine and Toxicology. And probably one of the highlights of what the Academy really brings is its focus on science. It's what probably converted me to the Academy to begin with, and then the great people to work with while I was here. So one of the things they do is scientific reviews. We'll talk a little bit about that. And but I've got two goals for the meeting, two goals that I want to accomplish. One, this is a bit more like a going to be a bit more like a workshop than a lecture. So what I'd like to do is each of those that are here that actually want to write a scientific review, I hope you'll leave with a topic, so you actually know where to go forward as you move forward. Some of those may be on your own. You may already know what that is, or you may learn it as we talk a bit about things today. And number two, I want you to have a clear understanding of what to do next, how you're going to do that. Now, the way we're going to make that happen is actually, this is the outline of what we plan to do. I plan to spend about 20 minutes talking, so if I can talk fast enough to get done that quickly, that'd be fantastic. If not, it may take a little bit longer. Then 10 minutes of questions. I know that there's normally the speaker's forum at the end, but I'd rather do it in this session. And then 20 minutes of individualized direction or attention. So, something that's started again, but happened a while ago, is a strategic plan for the IAOMT. And this was done back in 2012. And in that, they have one of their first goal was to have strong and effective capacity for IAOMT and its members. And point 1.2 is strong communication and active engagement among IAOMT membership. So the membership of the IAOMT, you'll notice under that first underline, is the strongest asset. The IAOMT's greatest asset is you guys, or us. So its members is its strongest asset, which I agree with. And the idea is to arm the IAOMT's greatest asset, or us, with current scientific information. Armed with that information, it actually provides the things that we need to do the protocols and the preferred methods that we use with our patients, that we actually see results with. And so the way to do that then is they also need to become effectively engaged and provide input. And so the way to do that is scientific reviews. So scientific reviews are one of the ways that we're actually accomplishing that goal. Said another way is it also wants, we actually need to actually articulate the IAOMT's position. So in articulating that position, we do that a number of ways, scientific reviews being about one. The other way is position papers. You may have heard of those. Those are probably a little bit, they are significantly more work than a scientific review, but exceptionally valuable for the IAOMT. And there's three main ones that I want to talk about today. One is I won't talk about them, I'll just mention them. One is our position paper on removing mercury or mercury amalgam fluoride or mercury amalgam and its risk to the population. Number two was one on fluoride, and that was just recently passed yesterday. You'll see that one was written by Griffin Cole, Dave Kennedy, and Amanda Just, and they just done a fantastic job. And Jack Cull, he was on there too. And then the other one is I mentioned Stuart Nunnally, who's revamped the osteonecrosis of the jawbone, or Nico lesions, as they were once called. So you'll see those. So that's one of the ways that we actually articulate the IAOMT's position on 3 of our positions. Oh, sorry. Number 2 is clinical practice guidelines, which I won't spend a lot of time on, but clinical practice guidelines are what physicians or healthcare practitioners use to direct their work. And what they try to do on those is collect a whole bunch of they collect all the protocols that people have applied, all the science that's behind it, and they come up with a protocol that's valuable for clinicians to be able to follow. The other one you'll notice is the SMART, or preferred techniques, through the SMART program, and many of you have done that. And the last is scientific reviews. So scientific reviews are what we're going to talk about today. Oh, I got to go through that again. Awesome. So why then do we want to write a scientific review? You guys are here. Why would you want to actually do that? So one of the main values for it is it's a repository of scientific knowledge for a given protocol, product, or material. So if you need to talk to a patient, or you need to talk to your colleague, or you need to talk to your board, heaven forbid, about something that you're doing, what you want to do is be backed up by science. Scientific reviews were instituted by Mike Ziff years ago. And the idea was they could go to the scientific reviews and actually see what's the value. What does the IAOMT actually believe about vitamin C? Or what do we believe about ozone therapy? Or what do we actually believe about mercury removal and how that impacts a patient? And what's the science behind it? Because that's what you need to know. So what's the data? So scientific reviews act as a repository. So if you ever need to do those, you can look to your scientific reviews. There's already 30 there that will help you and assist you in discussing that with various individuals. Number 2, you may want to actually get a fellowship or mastership. So as you spend more time with the IAOMT, you'll see that there's not only can you be a member, but you can be an accredited member, which means you actually are doing what you're supposed to be doing and have the necessary engineering controls to be able to do it. In addition to that, you can also get your fellowship and mastership. And in order to get your fellowship and mastership, you need to do a scientific review so that you actually contribute back to the society that has helped you gain the knowledge necessary to treat your patients so effectively. And so that's one of the key things that are necessary for a fellowship or mastership, is that you complete a scientific review. Another reason you may just want to share your knowledge. So the IAOMT is a wealth of individuals who know a wealth of knowledge on various topics. Not everybody knows everything about every topic. And so if you're really good at something, then we'd encourage you to write one just to share your knowledge so that everybody else might understand the data that helps support them in their own practices. And the last, you may actually find that it's an opportunity to publish. So some people have actually not only written a scientific review, but actually seek to be able to publish their information in peer-reviewed journals. And this is a nice stepping stone that will allow you to do that in a much easier forum. Okay, so what would we like you to do? Number 1, you'll need to choose your topic. That's often something that people contemplate quite a bit, and there's lots of ways to go about it. As you go about choosing your topic, what I want you to do is think about something you're passionate about. So the people that are most successful in writing a scientific review write about something that they actually care about, they actually think is important, and they actually want to know about it. So as you go to look for your topic, we'll do a little bit of a brainstorming session with you, but think about, what is it that I'm interested in? Are you really interested in the mercury that's surrounding your sterilizer? Are you really interested in how ozone impacts a root canal tooth? Now you'll notice that says 2008, so we already have a scientific review on that, but it's 10 years old. So you may actually just be able to update a previous scientific review, and that would be equivocal or equivalent of being able to accomplish a scientific review. So these are just a few topics you may be interested in. What's the ambient mercury vapor outside an extraoral vacuum? So we often use those in our office. What's the permeability of different barriers, different barrier devices that we may be choosing to use, and what kind of science is out there and available for them? What kind of impact does essential oils? These are just things that you can make up. Essential oils after dental treatment. How does high dose vitamin C, what's its impact after mercury removal, and what's its value? How does it operate? Homeopathic impact on periodontal status, or chloral activated charcoal versus DMPS or DMSA. So that was done back in 2007. Again, that's 11 years old. We could get a redo of that. So as you think about different topics that you may be interested in, just contemplate, how are those helpful? Okay, so how are you going to actually go forward on that? Okay, so The way to find a little known fact, all the scientific reviews for the Academy are online, and you guys all have access to it. We all have access to it. So here's how you actually access that scientific review database that's available for everybody. So if you'll go to the IAOMT website, up there you're going to see, let's see if this will, there's a little button right here. It's called Member Login. It's probably the biggest barrier for anything we do in our lives is we have to remember a name and password. You don't have to remember your name and password. You have to remember one phone number that you can get off this website, and you call Kim or Farah or Amanda and they will get you that. So don't think you have to remember it, but you can call them. You don't have to wait for an email back. Okay, so click that button right there and get past that barrier. Okay, once you log in, it's going to pull you to a page that looks like this, with a little title bar here. The one you're going to want is called Resources, and then you look up Scientific Reviews. Okay, that's where they're all listed. When you get that, you're going to get a long list. Okay, and these are the different scientific reviews that have been done under different headings. So this one is Biological Support. And there's a couple different headings that you can find one on, and from there you can decide what you want to look up. So this one is on DMSA. So how does that work with chelation therapy and dentistry? Bisphonic biophonic scanner. So you can go through and choose which ones you may, at the very least, this will be an opportunity for you to see what's been done, and it may twig something in your mind that'll help you choose a topic that is valuable for you. If it was done a long time ago, fantastic, update it. If it was not done at all and you can't see a topic, but it helps you understand something that you're interested in, go ahead. I think this is fluoride drops, tablets. I can almost guarantee you that Dave Kennedy's going to be on that one. So,
why does some say no approval?
Okay, so that's a good question about approval versus no approval. So after you're done your scientific review, it goes to the board to see if to have approval. Some things are board approved, which means it's an approved policy or procedure, something that we actually approve. Other things don't need any approval. It's a compilation of the science and valuable, but perhaps not approved by the IAOMT or the board. Not something that we necessarily want to stand behind in terms of expecting all our members to comply to. If that makes sense? Okay, good question. You also may see that there's some that they have no opinion on. So some products the board won't take an opinion on, because if they approve it, then you may find that that's choosing one product over another, and so the board's going to not want to do that. Okay. Okay, so that'll help you decide what topics you may want to choose. So as you go about now you've got a topic. Doctor.
Do we have a disclaimer for for those reviews? Is there a disclaimer sheet, something on the website for that?
Well, that's a good question. I don't know that. I don't know. I haven't looked. Although there's a disclaimer here I should have read. I do not have any financial interest in product of my talk. I don't get paid for what I do, and I don't want to get paid for what I do. It's fantastic. I love doing it, and there's no companies offering me grant monies for this continuing dental education or medical education program. So, okay, so sources. So as you look for sources, and I'm going to walk you through that process in just a second, any statement you make in a scientific review needs to be backed up by a scientific source. So if you make some statement, say mercury fillings cause Alzheimer's, what we need to know is who, by what authority. How do we know that that's actually of value? And so what we really want to see is that it comes from a peer-reviewed publication. And here's a list of peer-reviewed publications that have come, almost in order of value. They all have different levels of value. So a case study is a single study. So a study usually done on just a single individual or a single case. And it's actually, the data is recorded, so it's actually recorded, we actually know that it happened, and then it's reviewed by peers. So the problem is it's a statistic of one. So we don't know, is that just a unique individual, or is there actually something to that? And I think this morning's talk by Dr. Calabrese was fantastic on that very subject with hormesis, how he had to replicate his study enough times to actually see and quantify the difference on his studies. So the next is something called a cohort study. So rather than do it once, we're going to do it 1,000 times. And so you take a cohort, or usually however many individuals. That cohort can be 10, that cohort can be 1,000. But often what you'll do in a clinical study is you're going to to take this cohort of 10 or 1,000 people, and you're going to track them over time. So what's their outcome after 5 years? What's their outcome after 10 years? What's their outcome after 25 years? So you take that cohort and you decide, increasing your statistics and value. Often a cohort study, though, doesn't have any control with it. It's just we follow this cohort. We give them treatment and we see what the impact is. And the need for that is you don't necessarily want to not treat some patients. So that goes to the next one, is a randomized control trial, which is really the gold standard for clinical trials. And what that does is use a control group where they get no treatment versus a group that actually has treatment. You do it over time. And so they use that as the gold standard. So if you're looking for a research paper that you want to reference, this is what you want to reference. These are the good ones. What I've listed down here at the bottom is systematic reviews, and there's a little difference between review and a systematic review. So I hope I'm not being redundant here, but a review traditionally is done by an expert in the field. So normally, if you are an expert in some field, whatever that field may be, you've read lots of papers, you've been involved with many conferences, and you understand the topic. What you'll do is write a review, and that review kind of brings the population, or anybody who wants to understand it, up to a current standard, so we all know what the current level of knowledge is on a given subject. The problem with a review is it's done by an individual who may have bias, and that bias changes what he writes, and he will have an opinion, and that opinion will come out in the writing and, more importantly, in the studies he selects to discuss. A systematic review doesn't do that. A systematic review can be done by anybody, and the value of it is you have a specific search term, so that if I have a search term and Dr. So-and-so has a search term, and we all use the same search term, we're going to come up with the same data set, which is a whole bunch of studies. And we'll talk about how you pick those in a second, but we'll all come up with the same data set. So the only difference then will be how we discuss what the value of that data set is, which is a scientific prerogative. But what it means is the review should be the same. So a review that I do, a systematic review that I do on mercury fillings, should be the same as one Dr. X does and the same as Dr. Y does. We should all come up with the same data set and actually come up with the same conclusions if our opinions aren't changing the discussion. So that's why systematic review is valuable. Sorry about that. Okay, so that's systematic reviews. Other sources that people may want to use are textbooks, newspaper articles, personal communications, non-peer-reviewed articles, or personal experiences. Do not use these. Okay, that is not what we want. The problem with these are almost always just opinion. There's no authority behind them because they haven't been peer-reviewed, which you probably all know, but I just need to make that clear in a scientific review. That's what we want. We want the ones on the left, not the ones on the right. Okay, so how do we go about doing that? So probably one of my favorite sources is PubMed. If you're not familiar with it, you can just type in PubMed into your search engine and you should be able to find it. If not, you can type in the really long one, www.ncbi.nlm.nih.gov. You can also find it that way. In this, there's going to be a search bar, which I'm sure anybody you're all familiar with. I chose this topic a couple weeks ago, mercury absorption amalgam dental. Okay, because what I wanted to know is what's the absorption from mercury dental fillings, right? What do people actually get from that, and what's the current amount of science we have on that topic? So I type that into the search bar. From there, I get 175 studies, 120 first listed on this page. Okay, so these studies now, we want to comb through and actually find out what's the absorption of mercury fillings. So as I went through there, I found that number 6 says this. It's titled Mercury Exposure Levels in Children with Dental Amalgam Fillings, and I'll tell you why I picked that one. I thought it was interesting to know on children, which is interesting, and it tells me their exposure levels, and it's about mercury fillings. Perfect. That's something that would really interest me. I want to know what they get. And this was done in 2015, so it's only 2 years old. Okay. The other nice thing about this article is right here. Okay, this says free PMSC article. So what that means is it's open access. Everybody has access to it. You don't have to buy a subscription. It's actually the way science should be done, in my opinion. But nonetheless, it's not all articles are that way. This one is, which means I can open it up. So I click on that button, and voila, up comes the article. Full PDF, you can actually read the whole thing. If you ever read an article, let me give you a few hints if you don't mind. The best way to read it is skim it. Start with the abstract, and I'm not even sure I read the whole abstract, but if you want, the abstract is a really quick, dirty way to kind of find out what the objective was, and really then I skip down here to conclusions. That's the first thing I want. I don't get bogged down in the material, methods, or results. Skip that part. Same when you read the paper. Skip that part. Come back to it later, but just get the conclusions, just get the objective, and then if it interests you, now you spend the time and actually see how did they come to those conclusions. That's the important part. But that's typically how most scientists read a paper, or maybe it was just how I do. But very valuable. In the introduction, you're going to find a whole bunch of background, so useful. You'll figure it out as you go through it. But little tip, I suppose, is get to the end, start at the beginning, get to the end, and then decide how much interest you want to go to it. So what was interesting about this article is they studied 150 children. Of those children, they split them into two groups, those that had mercury fillings and those that didn't have mercury fillings. What was interesting is those that had mercury fillings had a blood or a urine excretion of 1.6 micrograms per liter. Which, they have mercury fillings? Sure. They also took those that didn't have mercury fillings and they checked them, and they found that they had 0.013 micrograms per liter, so a 100-fold difference. Which I think is incredible, like a major difference. So that's their excretory value of mercury in them, which I'm not sure, I don't know who these individuals are, because then they go on to say that though the mercury levels are different, they're insignificant. And I'm not sure how we want to talk about how mercury levels are ever insignificant. How heavy metals that come out day by day that you bioaccumulate, how any level is insignificant. Unless you're going to talk about hormesis, where you get it one day, and we talked a little bit about that this morning. So anyway, nonetheless, I don't have to agree with their conclusions, which I think are idiotic, but at least their data, their results, the really interesting section, and now that'll show up right here, which is really interesting, is there. They also compare that, I should just mention, just because I've got a podium and I can, they talk about fish. So those that ate fish was 1.3 micrograms per liter. That's what they get every day, and yet we tell people not to eat fish because they're going to bioaccumulate too much mercury. But a mercury filling, any child with mercury fillings is getting 50% more just by living every day. So, again, I don't agree with the conclusions, but at least I can understand. At least they have the data. So the data is really valuable. And then for a scientific review, you can use that and actually suggest it. So it gives us levels. So that's one way to do it. So that's a simple way to use PubMed to get the science, come up with what I do from there is read the results. That gives me an opinion, and you put that in your SR and back it up with the science that's been peer reviewed. Okay, you don't have to agree with their conclusions. The other way to do it, I'll just show you this really quick, is through Google Scholar. It's very similar to PubMed, but it's Google's method of doing so. Again, mercury absorption, I use the same search terms, type it into the search bar, I run a search, and now I'm going to get, 11,000 hits. Those 11,000 hits aren't going to all be valuable, of course, but it's going to prioritize them for you. And same thing, as you find the ones that are useful, you can just go right to the PDF if it's listed on the side. So this is where you're going to find the best science. If you come along here or you use PubMed, I should just go back to that, and you get something like this that talks about an article and you don't have access, you email me, or more importantly, Amanda Just, and she will find that for you. So the IAOMT is very interested in the research, and we want this data. So if this is important to you and to your topic, you let us know, and we'll make sure we get it for you and make it available to you. Okay? All right. So I have to go through this again. Okay. So that's where you get this. That's where you get the science from. You can do that before or after. It doesn't matter to us. If you want help along that process, then what you need to do is you need to start with this letter of intent. The purpose of the letter of intent is so that we know that you actually want to do this. This is something that you're really interested in. It's it's very simple to do. You put your name on it, your contact info, so we can actually contact you back. Why you want to do it, what you're interested in doing it, what the topic is that you're interested in, and how you think this will actually help the IAOMT. If you don't know, please don't get bogged down by that. But what we do expect is once you submit your letter of intent, we want you to complete your SR within 1 year. Okay? Once this comes into us, we will likely assign you a mentor, somebody that will walk you through the process. Because too many of our individuals in our academy actually want to complete science, but don't do it because they don't know how to start and they don't know how to move forward. So we've got several mentors that will help you, and many of them will help you today in moving forward on that. So that's the letter of intent. We need you to fill that out. What does the SR look like? So here's the scientific review. This whole top section is really mostly for office use. So I don't really want to, it's just office stuff. Don't get into it too much. You already talked about the approval, how the approval goes through. This is information of how to actually contact me and make sure that this is all going through. Here's the part that you'll be filling out at the bottom. Really just a whole bunch of empty boxes. So your name of your scientific review, you'll come up with a name. Alternatives for the name in case there's some other options that may be valuable for our members. Okay, and then you circle a few boxes, and then the purpose of the scientific review, which you'll have already decided, and then a brief discussion of what the SR is intended. This should be as little as a sentence to a paragraph, so that anybody who reads it can say, okay, this is the purpose behind it, this is why they're doing it, and this is what they found. Kind of like an abstract that we just talked about. The second section is actually to specifically describe the SR. You're going to want multiple paragraphs for this section. This is where all your findings come from. The value of the product, the value of the procedure, the value of the material. Okay, or the converse on any of those.
At the application level, you don't know that yet, do you?
This is for the final. So at the letter of intent, you're right. So letter of intent, you're right. You don't know that, right? This is the actual submission. The actual submission of your scientific review. This is it. This is what we expect. And so in that, you're going to make your points. As you make your points, you're going to define them with scientific articles. And then at the end, you're going to actually put those articles, those references. And they'll be formatted, and then we'll put them on the website for the whole academy to be able to benefit from. Okay, so I am getting to the end. I can tell I'm getting hands. That's perfect. I'm going to go through these slides. So here's the goal. I want to have each participant leave with a scientific review topic, and I want each of you to know exactly with what you need to do next with a clear understanding. Okay, so but before I end, I just want to say thank you to the individuals that have helped me along this way. So one is Phil Sukel, who can't be with us today. Great mentor, great friend, great guy, and great scientific background. Number two is Amanda Just, who is an incredible writer, great support, and just a lovely person. If you need help, she's the one to go to. She's just absolutely fantastic. Nestor Shapka, he just left the room, so we won't hear me compliment him, but great scientist, writes an incredible, very meticulous, and great guy if you get him as a mentor. Jack Call, he does so much for the Academy. I just really appreciate all the time that he spends, both for the Academy and for this. Tom Duplinsky, who's also a great researcher, has a great smile, and just a great guy, but never enough time. And Robin Warwick did research in her undergrad, which is very unique, all about mercury fillings, great person on the committee. And the last, Dave Reggiani, who's here with us today. Been with the Academy since its inception, and incredible if you can have him mentor you through this. So I just wanted to say thank you to all these people, and thank you to all of you guys being here. Okay, with that being said,
I don't know how to give code, because there may be someone who leaves a bit early.
Sure, you go ahead and give the code. Sure.
Do that?
Yeah, absolutely.
And then you could just work individually. So the code for this is R as in Romeo 18323 W as in whiskey. Romeo 18323 whiskey. Got it?
Okay. So, questions?
Well, I just want to clarify something. Dave Reggiani asked about a disclaimer on the website, which I just went to after logging in. And when you get to the scientific review page where it explains the general process and the program, there is a disclaimer, very short, states that IAOMT action does not necessarily show a preference for or recommendation of one product, technique, equipment, or publication over any other scientific review. So I'm not sure, Dave, what you had in mind, but does that cover?
That's what I was thinking about the other day, but I didn't remember where I saw it. We'll talk later.
Okay, so the question was, is there a disclaimer on the website? Jack Call just answered, yes, there's a disclaimer on the website. I just use the mic so that everybody can hear it, so that it's on the record. All right, general questions. Sorry, we stifled those a little bit. Dr. McKenzie, I knew we were going to have that happen. Okay, any other questions that would help the general public or the general membership? Dr. Young.
Going back to the PubMed, which I know a lot of you have to subscribe to, that will pay a fee.
No, there's no fee for PubMed. It's free. So you can use that search engine all the time from any computer, any website, anywhere. So PubMed is free.
Read the whole article.
You don't get the article. Yeah, the article is not free. So what it will do is if you pick, so this article right down here, So this, let's say we just take number 1, mercury levels in hair samples of dentists, comparative study in Sri Lanka. This one is probably not a free one, but it might be. But if you click this blue part, it'll take you to that, and you'll always be able to read the abstract. So the abstract is freely available to everybody all the time.
So that's what I wanted to clarify for everybody, so that how do you determine, as you go through Quebec, which one are worth paying some money to see the whole?
Correct, yeah. So if you want to know if it's worth, again, quick and dirty, you're going to go to the abstract. Oh, sorry, too far. Anyway, you'll go to the abstract and you'll be able to read it. You'll see the results there. They usually have the results in the abstract, and they usually have their conclusions in the abstract, which is good. What you won't really know is how do these results actually relate, and is it of great value? So to get the rest of the article, which is you'll need to do if you're going to write this, then you can decide that this is worthwhile having. I want this article, and then the IAOMT will likely help you get that article. Okay, if we don't already have it.
I remembered my question. So how many references do we have to have in our article? So
1 million. Okay, no, there's no hard and fast one. But for every statement you make in your scientific review, you want to reference an article.
And we can reference ourselves too, right? Our own scientific, like say I'm piggybacking on something somebody else has already done within our organization, I can reference their research, their scientific review, and then add on to it, is that correct?
Probably the same way, as long as it's been peer reviewed. So you won't normally want to reference another scientific review, although you could. Yeah, you can. There's certainly no reason why you couldn't, but what you want is peer reviewed. So you'll want an article.
If it says no opinion, or then don't use
That's right.
that one.
If it hasn't been published, it doesn't count as science yet.
Gotcha, okay.
Okay? Yeah.
That's my next question, is what if you're doing something like this?
So the question is, what happens if you're doing something that nobody's ever done before? You're actually doing initial research. That's another level. That means you're actually wanting one of the ones that want to publish, which is unique. If you've never published before, then perhaps you don't want to start that. That's a pretty big thing. People spend their whole career publishing. Like, that's a career. Most of us are clinicians, and so to publish is a difficult task. I would suggest you might want to start a little bit less than that. But if you think you can do it and you've got the capacity and the background and the support, then absolutely, if you actually get something published, for sure we would count that as a scientific review and we would utilize that information. And some of the best work, I mean, I'm glad Dr. Young brought that up. He's done some of the best science that we've had in the Academy. It's fantastic, but it's never been done before. But even with all he knows, it's still hard to publish. It's still a lot of work to publish. Okay, in the back there, Nestor. Christy?
So there are four possible outcomes: approval, no approval, and you said
No
they're all valuable. But I don't get it. If it doesn't get approved, then what?
So these are different. Those are more office or academy qualifications. It doesn't mean that it's not useful for the academy. They're all useful for the academy, right? Because what you're actually doing is compiling the known science for a given topic. That is valuable no matter how you do it. But the academy may not want to take a position on the research that you've brought up, for example. And so if they choose not to take a position on it, then you'll see that there's no opinion. If they don't want to approve it, means that they use those for, it means they don't want to necessarily stand behind it, because, and there's various reasons for that, none of which are coming to my mind as I stand up here.
So if it doesn't get approved, you can still have your scientific review.
Correct. Yeah.
Let's say accepted. I like that word because using the word approved gets kind of confusing. Like if somebody does a scientific review on safety of amalgam, claiming that it's safe, we're probably not going to approve that. We get too much evidence.
You're going to accept it?
But we'll accept it because
Yeah.
you did all the work
Oh, okay.
and you showed
The science behind it.
information that's available, the science.
Yeah.
We actually needed that information in one of the publications we had. We had to cite all the things that were opposed to us. So if somebody even did that, it is something that would be useful even though you think it would.
Okay.
So any science you do is always valuable. Those are the ways that the board will actually decide, or the academy will decide how we're going to apply that information that you've now compiled. Great question. Anything else? Okay. Yes, Amanda?
Did you want to mention to them that we have, I have a pretty loud voice for it. Did you want to mention to them that we have the SR manual too, that after they get the letter of intent, the things that you discussed today are actually written out in a manual that they can use?
Yes, I did want to mention that. Thank you for bringing that up. Thank you for mentioning it. So there's a manual. When you actually apply, as soon as the letter of intent comes through, you'll get a whole bunch more of information written that essentially does exactly what I've just discussed. So you don't have to watch me again on YouTube. You can actually do it in text form, which is a little bit easier for you. It's all written out. Okay. Yes?
I don't know if this helps anybody, but I have a granddaughter in university. My wife's working on a PhD, and she'd go in through my granddaughter's student number, and she'd get full availability of PubMed through the university for free.
Yeah, exactly. Yeah, universities, if you have any access to a university, universities would use a lot of that information. You have all those ones that are normally not available to the public, you'd have to have a subscription to, you can get through a university.
Is there also already a list of scientific questions that the Academy would like to have answered, that people can just take that as their scientific review?
Yes, but it's not as well compiled as we'd like it to be, but it is available. So if you do have, and I think you'll see that in the coming years, actually, that's going to become more available, and we're going to have more questions as each of the different committees start to bring that forward. And if there's questions from the Academy that they want answered, but they don't have the time to do it, then absolutely send them my way and we'll keep that list compiled. Yeah, that's great. Okay. All right, we're going to sit down with you. So the intent was to spend the last 20 minutes where we actually sit down and make sure you have a topic and you can start your topic and you actually can complete your search and move forward. So I've got Dr. Call here, Amanda Just, and Nestor, all of which will be happy to sit down with any one of you to make sure that you guys can move forward on your scientific reviews as you move forward. I assume that's why you're here, is to actually do that. So let's do that.